Welcome to more chemistry. The topic is valence electrons. What the? Oh yeah, valence, a term describing the outer electrons. In some sense, it's every electron that's been added into an atom's orbital since the last noble gas. You could memorize this pattern. I would. One valence electron, two valence electrons. Skip the transition metals as well as the intertransition metals, because that definition of valence electrons is kind of wishy-washy there, not so useful. Boron family, aluminum, 3 valence electrons, 4 valence electrons. Memorize that. Why are the noble gases so unreactive? Because they have a full outer layer. Their valence shell is totally occupied. We call it the octet rule, that every noble gas has 8 valence electrons. But of course helium only has 2, but one has 2, that's a full first shell, and so helium's unreactive as well. Here's a color version of the same thing if you're interested. Isn't that cute? Red, orange, yellow, green, purple, whatever. 1, 2, 3, 4, 5, 6, 7 valence electrons. But maybe even more important than memorizing that is understanding why, where it comes from. Oh yeah, this is the 1s1 element, the 2s1 element, the 3s1 element, the 4s1 element, the 5s1 element. And so since all these first family elements have their outer electron in the one electron in the s orbital, it's one valence electron. And the 2s2 and the 3s2 and the 4s2 and the 5s2 and the 6s2 and the 7s2 elements, 2 valence electrons. And the 2p1, 3p1, 4p1, 5p1, 6p1, 7p1 element, but let's see, in a sense that's 1 electron in the p orbital and 2 other electrons in the previous s orbital that have been added since the last noble gas. So 3 valence electrons, 4 valence electrons, 5 valence. So elements in the same family column group have the same number of valence electrons. Maybe that's why they have similar chemical properties. We'll talk about that in the next video. So here's the 1s1, 2s1. This is a nice one. I like that. Who made this did a pretty good job. And anyway, even though this looks like 6 valence electrons, you can't forget about, that's 2p6, 6 electrons in the p shell, but you can't forget about those 2 over there as well. So 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. I just snipped this from the internet. I have no idea what they're asking about there. I know the electron configuration of sulfur, but who cares? I'm talking about valence electrons. Another thing we do is Gilbert Lewis thought up this brilliant thing. It's so simple to draw 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots, 7 dots, or 8 dots around a particular element symbol to represent how many valence electrons it has. So just 2 for helium, but 8, 8, 8, 8, 8 valence electrons. And 5, 5, 5, 5, 5. Interesting. I see patterns. That's what chemistry is all about, seeing patterns. Here are the main group elements, ignoring the transition metals. So 1 valence electron, 2 valence electrons, 3 valence, 4, 5, 6, 7, and 8 valence electrons, except for helium. Sometimes that's called a duet, or a duet instead of an octet. Why do we care so much about valence electrons? Oh, I know. It's the reason why chemical reactions happen. The inner electrons, like the electrons for neon, don't react with anybody. They're just stable enough the way they are. But if I go just 1 less than neon to fluorine, fluorine's very, very reactive because it wants to get 1 electron from somebody, and it will do so no matter what. Oxygen's pretty reactive as well, because if it could just gain 1 or gain 2 electrons, it would look like neon in electron configuration and be more stable. So the oxide is more stable than the oxygen atom. Conversely, down here, if I only have 1 valence electron, sodium would really like to get rid of that 1, 2, 3s1 electron. This is a 3s1 electron in the valence shell. So this outer electron, very loosely held, very reactive, and that's what makes sodium as a metal very reactive. But when it becomes an ion, the sodium 1 plus ion is very unreactive. I wonder what calcium would like to do. I mean, to say, does the element calcium as an atom have a propensity to gain or lose electrons? The answer is, if it could only lose these 2 electrons, it would look like losing 1, losing 2. If calcium could lose these 2 electrons, it would still have 20 protons in the nucleus, but then only have 18 electrons. If it could lose these 2, it would have 18 electrons, and an electron configuration look just like argon. That's what makes calcium ions so stable, but the calcium metal is never found pure on the Earth because it's already been reacted. Well, that's the idea of valence electrons. We're going to use that a lot. Like I said, coming up in chapter 4 and 5, and again to help understand these trends in the periodic table. Thanks for watching, guys. See you in class or in discussion or in the hall.